Okay, before we officially start Module 3, Lesson 16, let's go over the last question from Lesson 15 homework and make a claim. Ready? Let's make a claim about what we see on this coordinate grid. All of the x coordinates are the same. Are you okay with me abbreviating it like that for now? The x coordinates are all the same. What do we notice about the y coordinates? What do you notice about the y coordinates? They are, each set is opposites. So when our x coordinate is the same, if we look at this one and we look at that point, it's almost like it flipped over what? It's the same distance from what? Everybody? Be more specific. 0 and 0 are over here. Nice. Exactly. The x-axis. So when your x coordinates are the same and your y coordinates are opposite, it's flipped over the x-axis. And Petros just taught you today's lesson. Thank you. I'm not splitting my paycheck with you, though. Okay. See, I think I'm funny. I guess not so much. Oh, thank you. Okay, so I pay for this so you can see that. All right, turn to lesson 16. Symmetry. You did symmetry in kindergarten, I'm sure. Did you find pictures of what letters have symmetry? If you fold it over a line, it matches up, right? You have a pretty flower, and you drew your lines of symmetry because if you fold, yeah. Isn't that similar to what we saw on here? What was our line of symmetry between this point and this point? What was our line of symmetry? Everybody? The x-axis. Because what coordinates were opposite? The y coordinates were opposite. And that's what we're going to practice today. So we already talked about opposites on a number line. So if this was our x-axis, positive 4 and negative 4 are the same distance from 0. Positive 1 and negative 1 are the same distance from 0. So let's take a look at the bottom of your note page, page 59, and this is going to kind of be a little pain in the tuchus because they want you to flip back from 59 to 60, but we're just going to focus on page 60. I'll have this up on the board. The first thing they want us to do is to locate and label the points 3, 4, and negative 3, 4. So here is, first of all, what's missing from this grid? What do we keep forgetting? Everybody? So let's label our x and y first. So 3, 4, negative 3, positive 4. So let's look at what they have in common. What do those 2 points have in common? What's similar? The ELA is coming back in again. First we made a claim, and now we're looking at similarities and differences. So what's similar?
The 3/4 and the negative 3/4, both the 4s are the exact same integer number.
Same y coordinate. Exactly. And the x coordinates, what can we say about the x coordinates? You might have to take a step away from it, but what can we say?
You could say they're opposites.
They're opposites, but that would mean that they're different. They have the same absolute value. So on your chart on page 60, you could write this in the top box. So what do they have in common, these 2 points? They have the same x coordinate. I'm sorry, y. They have the same y coordinate, and the x coordinates have the same absolute value. Okay? What is it? Not really.
You know the toy, the yo-yo? What letter does that start with? Y. And when you play with the yo-yo, which way does it go? Up and down.
In my
Which way
eyeball.
does the y-axis go? Up and down. Think of the yo-yo. That will remind you of the y-axis. And the x-axis, what's that instrument that you play? It's a whole bunch of keys and you hit it with hammers. What is that called? A xylophone. What does that start with? An X. So there's your xylophone and there's your yo-yo.
I would say the tail of the Y drops down and the X is just cut off. I like yours a lot better. Alright, so what's different between these 2 points? They are in different quadrants. They are in different quadrants.
The ordered pair is different.
What about the ordered pair is different? Be more specific. The x coordinates are opposites. That's right. Now, what's the same about their location? Now, when we're talking about location, we're talking about their relationship or distance from one of the axes. So what can we say is the same about their location? Where are they both located? Where are they both located?
3 units away from the y-axis.
Which way away? You said they're 3 units away. Get more specific. 3 units up, or 3 units above the x-axis. What else can we say? They are both, oh no. They're both 4 units. They're 4 units above the x-axis, but they're both also what? They're both 3 units away from the y-axis. 4 units above the x-axis and 3 units away from the y-axis. Now we couldn't say away from the x-axis because we were able to be more specific, meaning above. Why couldn't we be more specific about their location from the y-axis? How come we had to say away from when talking about the y-axis? They're opposite, so that means one is to the right. So that's the difference in their location. One point is 3 units to the left of the y-axis. One location is 3 units to the right of the y-axis. So we're not looking into anything that crazy. It's actually quite simple. Where is it? If you had to explain where it was, is it 3 units left, right, up, down, top, bottom? Now the last one is a longer answer. We're going to condense it a little bit. And this is the only one we're going to fully write out the answer for. The relationship between the coordinates and the location on the plane. So the x coordinates are opposite numbers. So they're on opposite sides of the y-axis. And that's what Petros pointed out in the beginning of class. If the x's are opposite, it's a reflection over the, which one? The y. So if the x's are opposite, oh come on, I just made my highlighter. So if the x, seriously. So if the x coordinates are opposite, then the y, really just one of those days, opposite sides of the y. And that's because they have the same absolute value. They are the same distance from the y-axis. So basically, this is just a big, fancy schmancy way. Here's the key word that I want you to know. Let's cut to the chase. To reflect. Why won't my highlighters work today? You think this is funny, don't you? Yeah. Reflection. It's called a reflection. So when they're on opposite sides of one of the axes, it's called a reflection. And that's the key word that we want to take away from today's lesson, okay? Don't worry about copying all of those words down. I just want to take a look. You don't have to copy the next two columns down. I just want to talk about it and then do some more practicing. So let's go back and look at the first picture we drew. Here were the 2 points. What was the same? What was the same? What was the same? Which one? The y coordinate was the same. I went backward. Oh no, it didn't go back. No. Okay, let's just skip ahead to this one. This is not cooperating. Negative, positive 3, positive 4, positive 3, negative 4. Which are the same? The x's are the same. So it's reflected over the which are opposite, the 4 and the negative 4. The y's are opposite, so it's a reflection over the x-axis. It's almost like if this was a mirror. It's reflected over the mirror, and you see it on the opposite side. The mirror could either be the x-axis or the y-axis. Okay? So if the x-coordinate is the same, it reflects over the x-axis. If the y-coordinates are different, it reflects over the x-axis. If the y-coordinates are the same, it reflects over the y-axis. If the x-coordinates are different, it reflects over the x-axis. And we're going to practice that and look at it some more. And the reason that works is because of their absolute value, their opposites, and the same distance. If I move this point up, is it the same distance away from the x-axis? No. So is it a reflection? No. Has to be the same distance. What about this one? 3, 4, negative 3, negative 4. Hold the phone. This is craziness. Did we reflect it over the x-axis? No. Did we reflect it over the y-axis? No. Are my x-coordinates the same? No. Are my y-coordinates the same? Both coordinates are opposites. So which axes did I reflect it over? Both. It's reflected over both the x and the y. Do you think it matters which we did first, the y then the x? So if we did it over the y and then the x, we would still land there. If we did over the x then the y, we would still land there. So it doesn't matter which one you reflected over first. They refer to it as the reflection over both axes. Okay? You haven't heard that up in 8th grade.
Yeah, we reflect through
Do you think
not
so?
yet, but we read both.
Okay. All right, so let's practice this. Let's take a look. S is plotted for us on this grid. This is in your notes on page 61. So the coordinates are 5 and 3. I want to reflect that over the x-axis. If I'm reflecting it over the x-axis, which coordinate stays the same? I'm reflecting it over the x-axis. Which coordinate stays the same?
The x-coordinate.
which coordinate do we take the opposite of? The y coordinate. So those would be the coordinates when it's reflected over the x-axis. Suppose I took that original point and reflected it over the y-axis. If I'm reflecting it over the y-axis, does my x-coordinate stay the same, or does my x-coordinate become the opposite? Opposite. So I have -5, and my y-coordinate stays the same. And we proved that in the first example. If we're going to reflect it across the x-axis and then the y-axis, so two reflections mean I have to have two opposites. So it would be -5, -3. And if I did the y first and then the x, it would still be -5 and -3. Let's try the next one. It's not on the grid, but we don't need the grid. We know what the rules are. If my point is -2, 4, and I want to reflect it across the x-axis, which coordinate stays the same? Yep, the x-coordinate stays the same. And the y-coordinate, we take the opposite. We're reflecting it over the y-axis. My x-coordinate becomes the opposite, and my y-coordinate stays the same. If I'm reflecting it over the x and the y, which coordinate do we take the opposites of? The opposite of -2 is 2. The opposite of +4 is -4.
With the first two we just did, because we said that -4 stays the same, but then negative.
Because if we're reflecting it over the x-axis, the x stays the same and the y is the opposite.
Yeah, but then the second one say
Reflecting it over the y, so the y stays the same and the x becomes the opposite. Good question. Try the next column. 3, -2. If I'm reflecting it over the x-axis, what are the coordinates going to be? Huh? Let's do this. Maybe this will help. Whoops. Should I spell it correctly? Would that help? To reflect over the x-axis. I hope you're writing this down on your notes somewhere. So x comma y becomes x comma -y. X comma y becomes negative x comma y. Have this reference out. Oh, I'm so upset. You had all this copied down? Okay, good. Then I'm not upset anymore. This would be a great reference sheet to have out when you're doing your homework tonight. How many of you are feeling a little shaky on this? Okay, I think what we're going to do is work on this again tomorrow, but still you should be able to do your homework tonight. Take a look at this reference sheet and let it help you. I am going to have extra help again on Friday since there was no extra help on Monday. Okay, so this Friday there will be extra help again. But I copy these rules down, and this is something you should be studying in addition to the notes that you took yesterday on the rules and the claims that we found. Okay? Does everybody have this copied down? We can go back and try some more.